All right, everybody. I have the top of the hour, and I want to welcome everybody to the NCAT from Research to Implementation webinar series. We've got a really fun topic this month. It is using BMD trial projects to build agency and industry buy-in, and that is so important if we are going to move forward with BMD as our main mixed design style and the way that we intend to build our pavements in the future. We need to have buy-in from folks that are the boots on the ground across the agency, and we certainly need to have buy-in from the industry partners who are the ones that physically build those roads. So today with us, as always, we have Nathan Moore, who is the Assistant Director for Test Track Research here at NCAT. He leads the research program at NCAT's 1.7 mile oval. It is an accelerated testing facility. Nathan got both his bachelor's degree and his master's degree from Auburn University, and he joined NCAT in 2017 after he previously had worked as a co-op student. Nathan's work focuses on asphalt mixture production, performance, BMD, pavement friction and surface characteristics, and also construction and evaluation. In his current role, he coordinates the test track experimental program, works closely with agency and industry partners as we turn the research concepts into full-scale implementable pavement projects. And Nathan is also a newly crowned Delta Airlines Platinum Elite member. So
The prize I get for not getting to be at home.
there you go. So we also have with us today Dr. Fan Yen. He's a research professor and an assistant director here at NCAT, where he leads research in BMD, advanced pavement material characterization, and sustainable pavement materials. He earned his PhD and his master's degree from Texas A&M, and he got his bachelor's degree in Southeastern University in China, where he grew up. At the 2026 TRB, Fan received the Academy of Pavement Science and Engineering Outstanding Academic Award in recognition of his contributions in pavement science, research education, and professional service. And he is a proud father of about 18 months old now, Kyle, who he named after the football stadium there at Texas A&M. Next would be Giselle Carrizo. She's the Flexible Pavement Sections Director for Texas Department of Transportation, Materials and Testing Division. In this role, she oversees the flexible pavement quality programs for the state and provides technical support to the districts and industry. Prior to this, Giselle was the Austin District Laboratory Supervisor and a pavement and materials engineer for the Texas DOT. She earned her master's degree from the University of Texas at El Paso. She's also a professional registered engineer there in Texas. She brings extensive experience to the materials and pavement performance, quality assurance, and the implementation of new technologies within TxDOT. She also has three sons who are very busy, two in college, one that's, I guess that's just about to start high school, maybe eighth grade. And notice her tan, just got off vacation. So, given all that, I want to remind you a couple of different things here. Let's make sure that you keep yourself muted. If you have any questions, please type them in the chat box. I'm going to kick that up for you here in just a moment. And given that, Nathan, please take it away.
Great. Thank you, Travis. I do want to reiterate what Travis just said, which is if you've got questions, these webinars are really mostly success. Most of the success from them comes from the interaction between participants and our presenters. So I would strongly encourage you guys to blow up the chat box, ask questions. We've got a really great topic today and some really knowledgeable folks here presenting. And so as you have questions, go ahead and get them in the chat. You don't have to wait till the end. Sometimes, somebody, one of the presenters or myself or Travis will be able to answer the question kind of quickly. Other times it's a great opportunity to put a pin in and save it for the end for some discussion. But please, please, please go ahead and get questions in as you think of them. So I looked through the attendees list, and many of you guys are regulars, and so you don't need this. But for anybody who might be new, just the way that this is going to go, I'm going to introduce the topic, but nobody's on here to hear me talk, so it'll just be sort of a very brief introduction to what we're talking about today, and then I'm going to kick it over to the experts. And so then that'll be Fan will talk about some work that we've done with balanced mix design is specifically for Texas, and some other work probably on the test track, and then we'll kick it over to normally it says we have says industry, but there's just somebody kind of in the real world. In this case, it's our agency friend from Texas DOT, Giselle. And so that'll take us to close to the end of the hour, probably about 15 minutes till, 10, 15 minutes till, and then we'll have opportunity for questions and then resources and close out. So trial projects at NCAT. Really, the first BMD field projects were on the test track, which I can't spell track. I apologize for that. Test track in 2018. I have a note there that says, work in 2015 set the stage. You could really probably go back even further than that, but I like to reference back to our group experiment on the 2015 test track, which we called the cracking group, which really the point of the cracking group was, hey, there's so many cracking tests out there. Which cracking test best correlates with field performance? And that question was critical because if you were ever going to go to the field with balanced mix design, you needed some confidence in the tools that you were using to assess mix quality. So that was some foundational work at the test track. Although you look back about 10 years ago, and there was a ton of work across the industry and academic world and the research world trying to answer these kinds of questions. But 2018 was some of the first BMD style testing that we've done, although maybe a couple from 2015. Um, but BMD really it began in the lab with numerous studies. I'm showing you just one here. This is a report that we wrote, some work we did with CRH at four of their plants, really across the country, and then including up in Ontario, Canada, where in preparation for BMD potentially coming into these states, and these were from a handful across the country. It was how can we better understand how these mixes perform in the lab? But BMD in the lab only, it only really goes so far. BMD in a research facility and a research style organization, it really only goes so far, which is why it's so important to push to the field. So NCAT was involved, and I looked back through the history, and so I'm about 88% sure that some of the first field trial projects that we were involved in, and I say field, I mean non-research environment, non-test track environment, was in 2020, and that was with the Alabama counties where we helped develop a simple, I think Buzz Powell at the time called it a simple BMD specification, which allowed up to 35% wrap and had some minimum ideal CT of 50 and a minimum high temperature IDT of 17. Those numbers were they were gleaned from work on the test track, and since we were, the counties close by, with the counties that used this specification were close by to the track, so there was very, very simple kind of adoption of these numbers. So there were two counties, Houston County and Geneva County, who did a lot of this work. And in a 2 year period, they placed over 60,000 tons of BMD, simple BMD mix on the counties. And that's a really big deal because sometimes counties, they may not have all the resources that state DOT has, or that, or the state routes might have offered to them. And so the idea here is how can we better serve from the county's perspective, the county engineers, where how can we better serve, our constituents by producing good mix. And so Alabama counties were really proud of this, and so this specification now is even still active. What lessons learned as you move from the test track to the real world, or any research environment to the real world, you do have challenges. Um, Early challenges as we move from research to the field is lab equipment. Like how much additional equipment am I going to need that I don't have? What's the right type of equipment? What's the right load press I need to buy? Or how many environmental chambers or water baths do I need to have that I don't already have? Is there special jigs or software that I need to do? Are there more people I need to hire? Or maybe do we need to go through new training to better understand some of these test methods and procedures? Also, site conditions, right? I mean, you can go to the track, or you can go to a small field experiment where you can pretty accurately characterize the site conditions. But if you were paving 60,000 tons, like we just talked about, you're paving over all kinds of underlying layers, probably from something that could probably stand as a perpetual pavement to maybe paving just on top of a chip seal or something like that. So those that introduces new challenges, and it requires a lot of good planning. Normally, though, when you see balanced mix design implemented, you normally see asphalt contents increase. This was the case in Alabama, where the mixes that were former, county mixes for those types of routes, when BMD came, you did see an increase in asphalt content of 0.5% or even higher. And that number is pretty common as you start talking about to different even DOTs that have done the work of implementing balanced mix design. You see an increase in asphalt content. So yeah, of course, that does cost a little bit extra. It does make density easier to achieve. And then also, if for folks who have a long-term view in mind, it's important to note that you are creating a better pavement, a better product that should last longer. So the life cycle cost will be reduced. Um, the last thing to talk about that I'll make mention of here is, as you take balanced mix design to the real world and you're producing these mixes in multiple different asphalt plants and you're doing design work in different labs, um, there's going to be differences between design numbers, samples taken during production and hot and compacted hot and tested immediately, versus samples that were just put in a bucket and then reheated later. And that's a big challenge that I think our industry is currently trying to tackle and better understand. But that is also a difference. And so this is important as you create specifications to understand if we're going to require a number, at what point during the process are we going to pull samples and require testing, so that we make sure that we are getting accurate data to represent that mix. So with that as kind of the background, Fan, I'm going to stop sharing and I'm going to kick it over to you to talk a little bit more about your work and with at NCAT on this.
All right, sounds good. Thanks, Nathan. Great job. Thanks, Travis. I definitely appreciate the nice introduction. For the group's information, Travis asked us to provide the bio for today's kind of like a speaker. I told him like surprise me, please, and that was a great surprise. So thanks, Travis. It's great to be on this webinar to talk about balanced mix design, and I'm sure like in many of you on this call knows the details about the balance mix design, so we really don't need to go through some of the fundamentals about the BMD 101. What I like to share today is kind of like, kind of like a piggyback to what Nathan brought up earlier. It's really about kind of like, some of the research, the highlight of the research on balance mix design that we have on the test track. In this specific case, we're, trying to showcase the great experiment that we have with, our sponsor, Texas DOT. This is really a nice case study illustrating like, the benefits of doing balanced mix design moving forward for, our industry. And, we'll let the data speak for itself. Over the last several years, there has been lots of discussions, lots of research, and implementation efforts on balanced mix design. If you go to conferences like TRB or AAPT, you run across lots of studies, try to kind of like tweak the mix design, if you will, because we know like many of the existing mix design that we do have, are kind of like not balanced in terms of, rutting resistance versus cracking resistance. In most cases, they have excellent rutting resistance, but not so much on the cracking side. So we need to kind of like change something as part of the mix design process to really improve, the property. As Nathan indicated earlier, that the key part of the balanced mix design is really using the mechanical performance testing. So by doing so, we're hopeful that we'll be able to improve the test result and eventually going to lead us to longer life. That's really kind of like the ultimate goal of what we try to do with balanced mix design. When we get life extension benefit out of it, then it provides us the opportunity to look into kind of like the long-term, cost savings and also the environmental benefits associated with that. So, that's really kind of like the expectation when we talk about implementing balanced mix design. But Many of the field projects we have seen so far across our industry are only a few years old, and we don't have that real long-term data to kind of like look into these analysis to see whether or not we can achieve those expected benefits. And then with that being said, TxDOT, approached NCAT, and then we were very fortunate to have the partnership with TxDOT on this experiment on the test track to truly leverage, the advantages of accelerated pavement testing on the NCAT test track to look into that life extension benefit of BMD. And that's really kind of like the focus of my presentation. So the focus or the objective of this experiment on the track, it's very straightforward. It's almost kind of like apple to apple comparison between the BMD mix versus the volumetric control mix. And then we put those sections next to each other and to see how they perform, right? I mean, that's real, in our opinion, that's a real test. In this experiment, TxDOT requested that we do overlay projects because that's kind of like the type of projects that they deal with on a daily basis. With 2.5-inch mill and inlay on the track. One very unique feature of this experiment is that we have fairly challenging underlying pavement condition. We have been very excited about this feature because that's does a really good job simulating kind of like what we have in the field. Because ideally we like to live in a world where like we don't have much underlying pavement challenges. It's everything is perfect in terms of pavement condition, and then we just do like the surface layer on top, and then it will perform like beautifully, right? But unfortunately, that's not the case. Lots of the payment we do like overlay or mill and inlay projects, we deal with like underlying cracking issues that will affect the cracking performance or the overall pavement performance of the surface layer. And so that's really kind of like the intent behind the decision to go with 2.5-inch mill and inlay over a challenging underlying condition for this experiment. This experiment we have on the test track included 3 sections, with 2 sections started in 2018 and the other one added 3 years later. So back in 2018, we did 2 test sections, S11 and S10, with S11 being the volumetric control section and S10 is a BMD section. Those 2 sections are next to each other, and they have identical underlying pavement condition from the previous test track, research cycles. So that provides that, apple-to-apple comparison on the field evaluation perspective. And then 3 years later, based on the lessons learned from those 2 experiments, TxDOT decided to add another BMD section to really play with kind of like a little bit difference in the mix quality, if you will, and to see how that affects the field performance. So that's why, like, if you can see over here, what I tried to highlight with my pointer, there's another section N6 added in 2021. That was 3 years later compared to the first 2 sections. Balance mix design, it's really kind of like vary from state to state, depending on kind of like what kind of pavement distressor you try to battle against, what kind of mixes you want to apply. In this experiment, TxDOT decided to focus on 12.5 millimeter SPC surface mix. Those mixes are all coarse graded with 50 gyrations. They all use the same component materials, but at different proportions. I'll give you more information on the next slide. All 3 sections use a PG7022 SBS modified binder, and they all had the same wrap binder replacements ratio. So that means like the RBR remains the same, but the wrap content, by weight of the mix are different because they have different binder content that are required to achieve that kind of like a spread in the test result in terms of rutting resistance and cracking resistance. Balance mix design is really kind of like a buffet table. That's kind of like the term that I've been using because there are so many different ways that you can use to modify your mix design to improve your cracking test result, at the same time try to maintain a good rutting resistance, and therefore to achieve that balance between those 2. Right, there has been, Nathan mentioned, like there has been lots of work trying to look into asphalt content, but we know asphalt content is not the only tool we have to achieve balance mix design. Some other work that has been done in our community include the one that I highlight here. Some look at gradation change, some look at play with recycled binder content, Some look at recycling agent, polymer modification, or lower temperature warm mix asphalt. So it's really, up to the contractor to pick which one is most cost effective, and at the same time can give them, the opportunity to optimize performance, meeting the agency's specification. In this specific experiment, UTEP, University of Texas, El Paso, they were the research partner involved in the mix design effort. The modification approach they took for this experiment was really to look into the gradation change, and based on that, to play with different asphalt content. I mentioned earlier that all those three mixes are coarse graded. So what they did from the mix design modification standpoint is really to further coarsen up the gradation so that you can create a more void structure within the mix that can allow more asphalt binder to be added into the mix, at the same time maintain your designed air voids, right? So that's just kind of like the way they did it to tweak the mix design. And then because of those changes, coarser gradation, high void structure, it gives us like higher VMA and higher VBE. As I mentioned, we still want to maintain that air void. So when you increase your VMA with your air voids, kept unchanged, your VBE going to go up. And everyone knows here that when we have a higher VBE, we anticipate to get a better cracking resistance, and hopefully that will give us a better balance between rutting and cracking. And that's really kind of like the modification philosophy that was taken in this experiment. So there were lots of design detail that, for the interest of time for today's presentation, I'm not going to share all those, but here's really a kind of like a quick summary of the mix design differences among the three mixes we have in this experiment. Once again, as I mentioned at the beginning, we have two sections from 2018, S11 being the volumetric control, S10 is the BMD. 3 years later, we added another BMD section, and that's the one on the very right side. There's lots of numbers here, but what I want you to kind of like pay attention to is really kind of like the total asphalt binder content that I tried to highlight here. So for the volumetric control section, the total binder content was 4.7. If you look at the BMD mix from the same, like research cycle 2018, that number increased to 5.5. So that's like a 0.8% kind of like unit increase in asphalt content. That's a lot, right? We know asphalt binder is the most expensive component. And Nathan mentioned earlier that lots of work that in the BMD era has been looking into like increasing binder content. So that's really kind of like one of the most effective ways to kind of like improve your cracking resistance. We know it's going to be more expensive because of the higher binder content, but the expectation is that with that change, it will give us better performance, longer life, and that will be able to justify that material cost increase from the life extension benefit standpoint. I'll share with you some exciting data later in the presentation. And then like 3 years later, like the other BMD section we did has also have a higher binding content compared to the volumetric control. But in this case, we were looking at 0.6% unit increase in total binder content compared to like the 0.8 increase for the S10 section. So overall, like if you just look at the number, like there were some significant differences in the binder content among the mixes. I mentioned on the previous slide that all three mixes use the same component materials, but the proportion of those materials are different, as you can see here. So I told you like the difference in binder content, how do those difference affect the test result? What I'm showing you right now is a very typical BMD performance diagram. In this case, we're showing like the overlay test, which is the cracking test for textile the BMD specification on the y-axis, and then the hammer wheel tracking test on the horizontal axis. The two dashed lines over here represent textile to BMD performance criteria for surface mixes. In this case, they are looking at the rut depth at 15,000 passes at the rutting criteria. Maximum rut depth is 12.5 millimeter at 15,000 passes for that PG grade that I mentioned earlier. And for the OT data, the parameter was CPR, the cracking propagation rate. A lower number indicates better resistance to crack propagation. So if you look at those two like tests and criteria together, what we want the data to fall under is kind of like the lower left corner of the diagram, and that's what we call like the sweet spot, the sweet zone. So anyway, any data point falls in that highlight area are expected to have balanced rotting resistance and cracking resistance. So that's just really like how the diagram works. Now, if we look at the data, I mentioned like S11 was our volumetric control section. If you look at the location of that mix on the diagram, it has really good rotting resistance in the Hamburg test, but not so much on the cracking side, right? It's above that maximum threshold number for the CPR of 0.45. So that means, like, relatively speaking, this mix is definitely on the dry side, has excellent rotting resistance, but not so much on the cracking side. As we started moving, the mix by modifying with as increase in binary content associated with the gradation change that I mentioned earlier, we started moving the data point into that sweet spot that I mentioned, right? As you can see here, starting from the volumetric, adding 6/10 more binder, we were able to move the data point kind of like right on the line of that, the sweet spot. And then adding like, 8/10 binder from the volumetric, we're able to move the data completely into that sweet spot. So that's really kind of like, all the test results, turn out just, exactly the way we anticipated. We know adding asphalt binary content going to be very effective in improving the cracking resistance. And in this case, both BMD mixes are still able to maintain that good rotting resistance. So that's what we got in the lab. But what happened in the field, right? That's really, in our opinion, the true test of the field performance. So what I'm showing you right now is the field rotting data. Keep in mind that N6 that was played 3 years later, so that's why like it has now been subjected to the same level of traffic compared to the other one. But in these plots, I'm showing like the rotting data versus the traffic in terms of mini easels. So everything, all three sections, starting from the kind of like the same spot, on these plots. If you look at this curve, there are some differences among the mixes, but the most important piece of information is that all three mixes shows excellent, rotting resistance. After 27 mini easels for S10 and 17 mini easels for N6, both BMD sections shows good rotting resistance with rot depth less than like 0.3 inches. And then typically on the rotting evaluation, we use a 0.5-inch threshold number as kind of like our failure limit. So now those mixes exceed that, and then the same thing with the BMD, with the volumetric sections, as you can see here. So based on what we see on the field, the rotting is really not a concern, and that matches or validates the Hamburg test result I showed you on the previous slide. So now the interesting part comes in with the cracking data, right? We showed you earlier that, some of those, the volumetric mix is not balanced because it does not have good cracking resistance, but the BMD mixes are balanced. So if you look at their field performance on the cracking side, I mean, this is where we saw significant difference. Starting from the volumetric control section, that is a blue curve here. So for this section, it started showing cracking somewhere around like 5 mini easels. And then once the cracking started, it propagated really fast. And then up to around like a 14.5 mini easel, that is where like it reached that 20% cracking length area threshold number that we use on the track in accordance with MAP 21 guidance. Okay, so it's almost like you can interpolate the data here as the life of this volumetric control section is about like a 14.5 mini easels. Now, if you look at the S10 BMD section, it was placed the same time as S11 volumetric control with the identical underlying condition. One thing you notice first is that like it took longer for this section to show like the cracking in the field, right? Compared to somewhere between 5 mini easels, we were able to delay that to somewhere between like 9 to 9.5 mini easels. Not only that, but also if you pay attention to kind of like the slope of the propagation part of the curve, the BMD section was able to slower the rate of the crack propagation. And that's what we saw, on the OT data. And, the field data just proved or supported what we learned from the OT testing. At this point, we have applied like 27, 28 mini ESOL to this section. It has accumulated roughly like a 17, 18% cracking, percent length area, but still under that 20% threshold number I mentioned earlier. For the other BMD section, it also shows like a much improved performance compared to the volumetric control section. But as I mentioned, because it was placed 3 years later, it did not have the identical underlying condition, which may introduce additional variable when we look into the apple-to-apple comparison against the volumetric control. But nevertheless, this mix still perform really well. After 16, 17 mini ESOLs, it has less than 5% cracking. So it definitely shows like the improved the cracking resistance of this mix. So if we only focus on the two sections from 2018, the blue curve versus the orange curve, the difference is really what we believe are the life extension benefits provided by the BMD modification, right? Those mixes, they have the same payment structure, the same underlying condition. They use the same material, but different proportions and different performance properties. And that's really the driving force, the driving factor for this difference we see in their field performance. I mentioned that, the BMD section have not reached that 20% limit, but let's just assume that, where we are, 27 mini ESOLs is kind of like the life of that BMD section. We are looking at roughly like 12 mini ESOLs life extension for the BMD section compared to the volumetric section. And that's really like, 80% like longer in life between those two sections. And that definitely shows the life extension benefit provided by the BMD modification used in this experiment. After we getting these field performance data, we did some preliminary life cycle cost analysis and life cycle assessment using the field performance data. We did the LCCA analysis using some of the guidelines information that TxDOT has been using. There's lots of assumption that goes into this analysis, but I'm not going to walk you through those details. But the most important part is that we're able to take the field performance data from the test track and then translate that into a life cycle payment maintenance and a rehabilitation schedule for hypothetical like overlay project or open highway in Texas, if you will. Because of their field performance difference, those are the volumetric mix and the BMD mix gonna have different kind of like overlay cycles, if you will, within the analysis period. So now jumping into the conclusion of this LCCA, because of the higher binary content in the BMD mix, we saw a 6% increase in the mix cost for the BMD section compared to the volumetric section. That's only the initial construction part of the story. But because of the extended life from the BMD section, we do see a 32% decrease in the life cycle, like net present value associated with the BMD section compared to the volumetric section. So that number is significant. It definitely highlights the life extension and also the cost saving benefit associated with balanced mix design. And then the same thing we saw on the LCA side, from the cradle to construction, we saw a 10% increase because of higher binary content, higher CO2 emissions. But when we look at the cradle to grave, considering the whole life cycle assessment, that is where we saw a 40% decrease in the BMD section compared to the volumetric section. So wrapping up everything, what we learned from this experiment is that the volumetric control mix showed good rutting resistance, but not so much on the cracking side. That's what we expected, knowing what we have seen so far in the field. The mix design modification for both BMD mixes significantly improved the cracking resistance, but resulted in some moderate reduction in rutting resistance. But that shift gave us more balanced performance between those two properties. The field performance data on the test track validated the lab test result in terms of relative mix ranking with both mixes, BMD mixes demonstrating a significant longer life compared to the volumetric control section. So the most important finding from this experiment is that implementation balanced mix design should be expected to improve mixture quality and extend the payment surface life. Even though like the initial cost may be higher for BMD mixes because of the modification required to achieve that balanced performance. But if we look at the life cycle assessment for both the cost and the environmental side, we see that benefit on the economic and environmental benefits. So that's really what we should expect with the implementation of balanced mix design. So that's really what we learned from the exciting experiment from the test track. Thanks to the sponsorship of TechStart for this exciting work. Now I'm going to turn the floor to our friend Giselle from TechStart for her to share the story that happened in Texas.
So good morning, everybody. I'm Giselle from Texas, the Texas Department of Transportation. Thank you for the invite. This is a quick presentation on how the department used the trial project sections to gain the agency and industry buy-in on balanced mix design. So everything started with an initiative, right? The balanced mix design, and this started even before I was in this position. And the goal was to, implement balanced mix design and use performance testing and also improve the economic and environmental benefits on our hot mix production. For that, of course, we had to have partners. Like everything that you decide to do, you need not just the agency to work on this big initiative, which it was, of course, the agency, which is our division, the Materials and Test Division, but also our districts. When I said districts, I know some states have areas. It's similar to areas. We have 25 districts in the state. And then also having universities working with us, it really helped and still, well, always helps, right? Having the research going on, and then contractors and material suppliers, and then the working groups, right? Not only our internal agency industry working group, but also our national working groups. So at the beginning, everything started with research, right? Developing performance tests, and tests that started using the Hamburg tests for routing performance, and then the overlay tests. Since then, agency and industry was heavily involved, right, in the implementation. So they were already kind of familiar on the whole process on implementing a new test, more on this type of test that requires more than testing volumetrics on our hot mix, right? It requires a lot of more equipment, more training for our technicians, development of new thresholds. As Fan mentioned, we started with our test with NCAT test track with our test sections balance mix design. And as we're getting these updates through the years, we knew and gave us confidence, not only to the agency, but also to contractors, right, on seeing how the test sections were doing and how they were even, doing so well that we decided to go to the next step. The next step was to start building trial sections through our districts. So to do this, we started talking to different districts to see within a project that they already had going on to see if we could have test sections, and then 6 districts were ready to do it. And even though we had 9 test sections, within those 9 test sections, we had different combination of materials. Maybe one section was with softer binder and the other one was with higher wrap. So we had a total of 33 test sections within the state. This allowed districts and contractors to also gain hands-on balance mix design experience, uh, but we didn't have like a implementable statewide specification at that point. The objective was to identify the challenges and build confidence. Then the second phase for balance mix design was more test sections, but now we wanted to see we can produce this mix not just for a smaller test section, maybe a couple of days, 3 days of production. For that, we had a total of 4 test sections with 8 different combinations in 4 different districts. When we were doing this, the Balanced Mix Design Working Group was developed. The goal of this group was to have not only the agency, but also industry participating in this formal group so we could, analyze all the data that we were receiving from our test sections and then seeing what were the concerns, what were the challenges. Also, a different group was developed within the agency, which is called TechStat Forum. The forum is a group of each district having a materials engineer or SME from each district that gets to review all these documents and all this information that we were getting and giving their feedback. So it was only the division that it was reviewing the new specifications, but also all the districts had a voice to make their comments and their concerns, and we could share this information to the Balanced Mix Design Working Group. So at the end of 2025, we were able to develop a one-time use special specification 3024 using all this data that it was collected from the test sections. The goal of this specification was to now use it in pilot projects. Pilot projects will give the districts the opportunity to use this balance mix design now since the beginning of the planning of the project, going all the way from letting, construction, using balance mix design. That way the agency and industry will get experience using this different new specification under like real contracting conditions. So last week, the El Paso District project started. It's been going on, and then we'll have Lufkin District starting next month. And then we have 2 more projects coming up in the following months. So what were the challenges of implementing balanced mix design? Of course, the increase on sampling and testing requirements. We're having ideal testing being tested every day. It is a lot of more testing than what we have in our regular QC/QA specifications. And of course, the new equipment, we need more space in our labs, right? Sometimes those labs and the hot mix plants, they're small, so that's a big challenge. And then also certification, having our equipment calibrated, having technicians that are certified to run these new tests. This test takes a little bit longer. They require curing of the samples, way more samples. That means greater laboratory workload and staffing needs and training. And then with all this information from the pilot projects, we want to verify our criteria, right? And get and see and verify that our current acceptance and payment criteria can be adjusted. but that's gonna be in the future, right? Maybe right now we're still gonna be paying according to herboids and lab molded density, but with all this new additional information that we're gonna be obtaining from these pilot projects, reevaluate through our working groups and and with everybody that has been involved in the development of the specification, what would be our next step? And then, of course, the most important, building district and industry buy-in through these pilot projects. Now, other challenges on the department's point of view is how we share all this information. We do have a lot of information and data gathered through these test sections, but how do we share this information to our districts and through industry? So as I mentioned before, we have our balanced mix design working group. This is, I don't know if I did mention, this is formed by representatives from industry, representatives from the agency, and we have also researchers involved in this working group. Also, we tried to present updates in our local conferences for the department whenever we were invited from our Texapa, which is our local, well, state hot mix asphalt a group from industry. And then also, they also have this partners in quality meetings that they schedule throughout the state. Every district will have a partner in quality meetings. That means the opportunity for that district personnel to meet with industry and talk about challenges or concerns that they having. So we've been presenting these balance mix design updates through those meetings. And then also we have just formal balance mix design updates meetings with those districts that have test sections. So we set up virtual meetings and then we meet with those districts that have, similar test sections, and we've been presenting updates on how those test sections are doing. And then also finding ways for us to get their input from, it's a lot of people that are being involved in this initiative. So of course, getting information from national working groups like NCAT and seeing what other states are doing, what type of tests they're running, what's the frequency. All this is real good information. And then also through our Balance Mix Design Working Group, getting their feedback. Like I mentioned, Texapa, our industry, local groups, AGC reviews, and then our TechStat forum. Lessons learned, of course, it's been a long way, right, to trying to always involve agency and industry through the whole process of balance mix design implementation. Using the trial projects has helped us to reduce implementation risk. And of course, sharing successes, but also failures, right? What didn't go well is also a learning process. And we wanted to get all the feedback, something that wasn't working, we needed to know. And then also establish a formal agency industry working groups. Of course, let the field data drive the decisions. And build confidence before implementing new requirements. And of course, buy-in is achieved when you get a lot of people participating and being familiar with the whole process. So communication, communication, communication. I think this is my last slide, so I'm gonna pass it to Nathan.
So first of all, thank you, Fan. Thank you, Giselle. That was excellent. Very, very practical. I think this is topic of a lot of interest across agencies interested in balanced mix design. So just a few recommendations that I take away from listening to these two wonderful speakers. The first one, I think, maybe self-explanatory, but implementing BMD requires thinking outside the box. That means thinking outside the box of traditional super pave. It may mean thinking outside the box of mixed procurement, possibly, and um, specifications. It's going to mean thinking outside the box in terms of materials or costs, equipment necessary, expectations and standards across the board. Nobody said this was going to be an easy process, but I'll get to it in a minute. But I thought Fan made some really compelling arguments for why balanced mix design is the way to go when moving forward. But BMD mixes, they will look different than traditional mixes. Primarily, I think we're going to see that in asphalt content, but you may see that also in things like recycled material. Ultimately, if you say, listen, if you tell me that the mix can pass these vetted laboratory criteria, then you know, put more recycled material in there and reduce, cost to contractors and ultimately cost to the agencies. Maybe it means different gradations. Maybe it means introducing additives. I was speaking to some folks in Missouri, even today, about how much rubber is being added into mixes here, and I know our friends in Georgia are doing that. They've got a specification for that as well. So those types of mix changes should be expected to come alongside with BMD. And those mix changes are going to cost more upfront too. I think we just need to be honest with ourselves and recognize that they're going to cost more. However, the concept of price anchoring is very real, and that is we have anchored our expectations for how much asphalt mix should cost off of mixes that across the country are on average too dry and not sufficient for meeting the needs of the traveling public. So, yes, they may cost more, but I think it's worth it. BMD and changes to mix designs like this, it will bring longer lasting pavements, and longer lasting pavements will equate to lower life cycle costs. It'll equate to lower life cycle emissions. So less strain on future maintenance budgets and resurfacing budgets and rehabilitation needs. Um, so yeah, it is we are sort of building this brick by brick, but it's worth it. And Fan has a really wonderful case study that was developed in conjunction with the work that Texas DOT sponsored on the test track. But those case studies are all over the country in places that have implemented this. I see there were some folks on the call from Virginia who could probably tell you stories about this, and folks on the call from all over that have seen the value of balanced mix design and improve, and just even in general improving asphalt mixes and recognizing that it's worth it if we're having lower life cycle costs, more sustainable pavements, etc. But these types of changes are slow and steady. Um, you know, TxDOT has been working on this for many, many years. I know, folks, some friends in Virginia had like a 5-year plan, for example, to implement balanced mix design, and this is the case, and this is like smoking meat here where this is going to it takes a long time, but in the end it's worth it. Um, you can't microwave BMD. It is a big change. It's not just adding more asphalt to the mix. Um, there's a lot. So, slow and steady wins the race in this case. Shadow projects, trial projects, where you're partnering with agencies and the agency and the industry is partnering with one another uh, to identify unexpected challenges. Like, hey, I didn't realize that this was going to be the case, or I didn't realize that my workforce was going to have to be required to sample this much, for example, or I didn't think that I didn't have the oven space necessary to age specimens or keep them hot, for example. But it also gives hands-on experience. And I thought Giselle's point was key. The main point here is really to build confidence. You're not trying to change the world with trial projects or shadow projects. You are on a fact-finding mission to go and figure out what are the challenges that we need to overcome as we proceed toward implementing balanced mix design. So those lessons learned, those challenges, they then turn into pilot projects where, draft, special provisions are developed, and you take those lessons learned, you bundle them up into a specification, you initiate pilot projects, and then you don't just pat yourself on the back and stop. You continue to monitor, you continue to collect data, you continue to interface between contractors and agencies and continue to learn lessons to slowly but surely build this more and more and more. And you do need to prepare for, additional possible personnel needs, updates to equipment. One of the big ones, everybody thinks about what kind of load press should I buy, but I remember some of the first contractors that I was talking to in Alabama as they were doing that county work spec, as they realized like we don't have the oven space necessary. So how can we take BMD and not require contractors who may be in rural areas and really small QC lab trailers that don't have extra countertops? How can we do BMD in places like that where they only have room for a single oven? Like things like that are that's just as an example of a uh, of challenges that need to be overcome. Um, and then I thought that Giselle's, her final point was, I thought was key, and that's honestly the reason why we asked her to be a part of this. Developing these working groups where agencies and industries say, we're going to come together, we have the common goal of improving asphalt mixes across the state, but we want to make sure that we do this honestly, fairly, consistently, and appropriately. So you share successes and failures with one another. And then I didn't sort of add it on here, but uh, communication, 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 absolutely critical for something like this. We don't need to live in our little silos, even within an agency, materials folks, construction folks, planning folks, maintenance folks, even within an agency, we need to have everyone needs to be bought in and have a voice to share successes, share failures, share lessons learned. And I thought Texas, you guys have just done a tremendous job of utilizing trial projects to collect information. So well done, and thank you for participating today. So with that, I saw there's quite a few questions
There
coming
are.
up in the chat. So Travis, I'm going to kick it back over to you. Thank you, Fan. Thank you, Giselle.
Cool. Cool. Such a timely topic. I really like this, and I really love how driven this is into the implementation of BMD in Texas, and I love that map that we get to see sometimes of all the different districts that have used this, the different counties and so forth. So one of the things that came up, and it's kind of come up a couple times, and I see there's some discussion going on in the chat group there, but I really like this one. I think it's worth a discussion, and I think all three of you really have a good perspective on this. But what kind of correlation have we found in the data between the ideal CT testing and, say, the overlay testing? Are we finding that both of those relate to the field performance? Do they correlate well with each other, etc.? So, Fan, you want to take that one first?
Yeah, I'll be happy to. For the BMD experiment on, the Texas BMD experiment on the track, we did run ideal CT as well, including different aging conditions. We have some good correlation or good agreement between the two, because once again, this experiment is all about binder content and gradation difference, and both tests seem to do a really good job capturing that. I would say like we have also seen some other data where those two tests may not correlate strongly because of the nature of the test. But in terms of picking up a dry mix or difference in binder content, those two agrees really well. So.
Okay, Giselle?
Yes, and I don't think I did mention for our test sections we have TTI collecting performance data every year. So we're going back, retesting, reevaluating if there's new cracks or rutting. So we're correlating our initial testing on ideal. Everything was run ideal, CT, RT, Hamburg, and overlay, and correlating that with the actual performance of our test sections, kind of what NCAT is doing, but for us, for our test section, it's taking way longer, of course. But we do see a good correlation between performance, right? If we had a low well, acceptable, ideal test results. It is correlating with what we actually seen. Of course, there's no perfect correlation between these tests because of the nature of the test. I know there's variability within the 4 tests that we are using, but if something was passing, um, the ideal testing was also passing. And I see Amy online, and she's way more familiar with the actual data from the test sections. Let me see if she can add more to my response. Amy?
Yeah, howdy everybody. Thanks for this webinar. I think it was great. I just wanted to mention that, yeah, we have been doing the repeated load tests as well as the ideal tests, again, to try to build confidence in what had been being used traditionally at TxDOT and what we're trying to move forward with. Primarily, the driver has been to do verify mixture performance during production, which we all recognize we can't utilize those repeated load tests in that setting. What we have been doing is looking at those different tests versus the measured field performance, as Giselle indicated. So one thing to note is in the 7 years that we've been doing this, we have not changed sort of our initial criteria. So as she mentioned, there's variability. There's more variability in the cracking tests than the rutting tests, as would be expected. But and you can't bat 1,000. You're not going to get something perfectly correlated. But we have seen that enough correlation that we feel confident so far going forward with the thresholds that TxDOT has established. I don't know if that answers the question.
All right, good deal. Nathan, want to get your perspective on the correlation between the ideal CT and the overlay.
I think that we've seen enough in our laboratory. TTI has done a ton of work on this as well. It's not a perfect correlation. I think Fan made the comment about both tests can sniff out a dry mix pretty well. I'm a big fan of the overlay test. I think it is a wonderful research tool, and especially if you're trying to understand the impact of different materials. Ideal CT is just simpler. So, from a balanced mix design perspective, if you're going to do, if you're going to need rapid testing, it's got to be the ideal CT. But the overlay test is a wonderful, wonderful, wonderful test. You just can't do it during production.
Yeah, and so much quicker too, right? I mean, that's the thing. Ideal CT is so much quicker as well. So I like that. Nathan, one of the questions that had come up in here when Fan was talking about rutting was how rutting is measured on the NCAT test track. Can you cover that real quick?
Yeah, we use, and I saw Jason Nelson chimed in, which is great.
Yeah. Yes.
So yeah, just using our profiler van and the laser measurement systems that we have on there. We measure rutting every week. If you look week to week, numbers jump around sometimes, although generally they are pretty consistent. Every once in a while, you will see some jumps, and I think that we saw that on some of Fans' data, and that can be affected by patching and other just maintenance operations that are going on. But
So
on average, I think those charts should be looked at big picture, and there's frequently little aberrations. And whenever you're doing any type of field testing, I'd imagine that Texas DOT's and TTI's plots as they're monitoring field sections look very similar.
yeah. Yeah. So there was also a question in there that was talking about what some of the different limits were, or what your ideal CT threshold was going to be. And Giselle, I noticed that you put the Texas DOT's table up there that gave us a good indication of that. Do you want to go ahead and kind of just talk through what you put up there so that folks get a good idea? And then I'll save that and have that put into the video if people come back and watch the recording of this later.
Sure. So for our Hamburg, we do have it by PG grade, of course, 15,000 and 20,000 for 15,000 for 70 PG grade, 76 or higher is 20 passes. And then for ideal RT, we have 65 for RT index for 70 PGs, PG 70, and PG 76 is a 75. Now for cracking overlay tests, we do use criteria fraction energy of zero point 0.1, crack progression rate 0.45. I know it's maybe a lot of people are not familiar with the overlay tester, but for our ideal, excuse me, CT, we have for a PG grade minus 22, we have an 80. And for a minus 28 or lower, we have a 95 CT index. I wanted just to add, we do have in our specification, and we can share our new specifications if anybody is interested. We always, during production, we running only ideal RT and ideal CT, mainly 4 times a day production. But if something is failing and the engineer wants to go back and run a Hamburg, they're allowed to do it, or an
Okay.
overlay test as a verification, since those tests are run in mixed design. So we do have a number that we can go back to, and also during a trial batch. So there's always those 2 tests that we have maybe a lower variability on our test that we can always go back and reference and see if it's really something going on with the mix or maybe with the test, right? So that's a quick
Yeah.
verification for the district to just to go back to those 2 tests.
And I think that's really neat that you have that 2 levels, right? So we have this production, things are going smooth. We can go ahead and use both of the ideal tests to make sure that our production is staying consistent. But then if we have an issue, we have built into the specification to go to a higher level to a test that we feel is a bit more extensive on that. I think that's a fantastic approach. Probably a really great way to have this dialed in for getting into the QA, because that's a big part of where people are asking questions from DOTs is how do we do the quality assurance with BMD and move this past just the mixed design phase. So this question has come up a couple times there, and Fan, I noticed that you've thrown your poster up there, but will you cover real quick the correlation that you've seen between the Holmberg wheel tracking and the ideal RT testing?
Yeah, absolutely. Long story short, these 2 tests correlate well, especially like when you have mixes that do not have stripping issue in Hamburg. But when you have those mixes, you got to be careful with how to interpolate your Hamburg data, because Hamburg is not just a rutting test. It does have that moisture damage component. So depending on how you analyze your data, if you focus on pure rutting parameters, then those parameters correlate extremely well with ideal RT. But the
And Fan,
poster,
that poster that you made, does that include the data from NCAT report 2601?
yes, it does,
Yeah.
and also
Okay.
include a whole lot more data, not only from the southeast part, northeast,
Yeah.
and I think we cover like more than 60 different mixes from
Yeah.
different places. So
Great. Perfect.
Cool. Cool. Well, Nathan, you want to give just an idea of what's in that report 2601, and even do you have some knowledge of the app that was created as well?
I don't know what app you're referring
Or
to.
the analysis tool? Or is that a fan thing?
oh, you're talking about the Hamburg stuff?
Yes, sir.
Okay. Yeah, that was just more like a tool, that a web-based a program that we developed, try to help users, agencies, a contractor to standardize the calculation of any parameters you want to get from the Hamburg wheel tracking test. So,
Oh, yeah, that's right.
yeah, but Nathan can talk more on the NCAT report. So,
Well, it shows really strong correlation for preliminary data between all of the routing tests. The correlation shape and sort of parameters are a little bit different, but as long as they're not stripping involved, routing tests seem to correlate with one another better than cracking tests. It's not perfect, but better. Travis, I'm actually going to jump ahead. I know we're kind of running out of time, but I did want to circle
Yeah.
back to Grover's question about I saw it in the chat, something
Yep.
about um,
Oh, yeah,
cracking
yeah, yeah.
cracking tests or studies that don't just use additional binder.
Yeah. Yeah,
Um,
and I kind of was trying to tease some of the work that you had done on the side.
Well, what stuff I did was super preliminary at the time, and I think this actually been validated, through other laboratory experiments. But Grover, to answer your question, yes, there has been a lot. When BMD first started, and I remember when we started doing training classes in the late, 2010s on balanced mix design, all of our examples were asphalt content, and we would make the comment about how you can use other things. You can look at wrap percentage, and you can look at rejuvenator, and you can look at gradation and additives, but we didn't have a lot of data on that. That's really not the case anymore. We've got just tons of data on this, and it's not even just NCAT. You could look at, Amy was on here earlier. I'm sure she's got plenty as well, and Asphalt Institute probably does as well. But one of the simpler ones, is if you have a gradation that can be adjusted to make your asphalt work a little bit harder for you. I think that's the simplest thing that contractors have access to is, can you increase that VBE that Fan was talking about earlier? So the volume of your of binder is is a little bit, you want that next tenth of binder to work as hard as it possibly can for you, and oftentimes you can set it up for success just by adjusting gradation. What we've seen in the lab, which I hope to validate and see validation in the field, is as you move mixes coarser, some of your, especially the ideal CT numbers tend to go up. That makes sense, from a volumetric perspective, in my understanding, as you think about, film thickness and things like that. Whether that correlates to better field performance, I think the literature is a little less. It's not totally silent on, but I think it's a little less um, robust on. But I'm hoping that we had that we also found that in some work we did with Alabama DOT, and they're actually going to be making specifications changes that reflect that understanding that as mixes go coarser, ideal CT numbers tend to go up. A couple other examples of things like just reducing binder absorption. Like some of these things are really, they may be simple but not easy, but they are simple, which, reducing binder absorption, adjusting gradation to make more room for asphalt binder, things like
Hmm.
that. So
Hmm.
yeah, there's so many. Asphalt content, though, is just the simplest tool to think about as you're describing BMD to somebody who may not be as familiar. That's a really
Yeah.
good question, Grover.
Yeah. I like that. I'm glad that you doubled back on that. One quick question for you, Nathan. Where can people find that report that you mentioned, the NCAT report 2601?
Yeah, so you can find that on our website here. So these are specifically test track. What I'm showing you here is specifically information for the test track, but you can just go to NCAT's website, our research, and find it there, or you can just put it in whatever search engine of your choice. Just type in NCAT report 26-01.
Great.
All right, Travis, why don't you take us home?
Well, there you go. Visit us at ncat.us to find a whole bunch of that stuff. Always like to plug our training in your pocket out there. Lots of fun videos there that are easy, 3 to 5 minute for the most part. We also have the T90, or the training in 90 seconds in there, where we break things down in even shorter intervals there. But please visit us on YouTube for Training in Your Pocket. Next month, we've got another great topic out there. Nathan and I are very excited to have Tennessee join us next time. We're going to talk about their efforts in implementing thin lift asphalt pavements into their pavement preservation and their toolbox to make sure that they maintain their roads really well. So that QR code will take you to the link, and put yourself on the calendar for September 17th at 10 a.m. Given that, Giselle, thank you so much for joining us, Fan. Always a pleasure to have you here. Amy, thank you for your insights in here. Nathan, let's sign off till we see folks next time.